Use the first principle to find the derivative of y is equal to sine of x. Now from the first principle, we know that the derivative dy over dx is going to be equal to the limit as h approaches 0 of the sine of, sorry, before then let me write the formula. The limit as x approaches 0 of f x plus h minus f of x divided by h. And so this is going to give us the limit as h approaches 0 of sine. Now in sine where there is x, we are going to put x plus h minus sine of x divided by h. Now we know that sine of x plus h, that is a double angle, and we can expand that from the double angle formula. So that is going to be sine of x and then cosine of h plus sine of h cosine of x and then minus sine of x divided by h. So I'll put what has got sine of x together. We can see sine of x here, we can see sine of x there. So I'll put that together and factorize out a sine. So that will be limit as h approaches 0. So this is limit as h approaches 0. I'll remove a sine from here and here, the sine of x. So that will be sine of x. And then what is going to remain here is cosine of h minus what will remain here is a 1. And then we have got plus sine of h cosine of x, everything divided by h. So at this point I'm going to split these two limits. So this is going to be limit as h approaches 0. We are going to have sine of x cosine of h minus 1. I'll divide that by h and then plus another limit as h approaches 0, and then we're going to have this side sine of h and then cosine of x, but the h applied to both, so it will also be here because the h is dividing everything. So from here now I'm going to write it as limit as h approaches 0. Now since this is a constant sine of x, we can see we are talking of h. H is the one which is approaching 0. That means sine of x is a constant. I can bring that one in front. So that is going to be sine of x and then put limit as h approaches 0. Now we have got cosine of h minus 1 divided by h and then plus cos x is also a constant in this case, so that is going to be cos x in front because our limit is for h approaching 0, not x. And so now I'm going to write the limit as h approaches 0 of sine of h divided by h. So these are some special kind of limits which we need to know. We need to know that the limit when h is approaching 0 of sine of h divided by h, this is always equal to a 1. That one we just need to have it in mind. This is a special limit. As long as this angle is equal to what is in the denominator and the limit is approaching 0, then that is equal to 1. Another thing that we need to know is when you've got cosine of h minus 1 divided by h, as long as the angle which is here is equal to what is in the denominator here, that one, the limit, where we write it as the limit as h approaches 0 for 1 minus cosine of h over h. This is always equal to 0. As long as this angle which is here is equal to what is in the denominator, it's always equal to 0. So I can as well write this which I have. Now I've got cosine of h minus 1 instead of 1 minus cosine of h. So I can write this as sine of x and then you have got limit as h approaches 0. So I can say this is I can factorize out a negative. Now what is going to remain is 1 minus cos h divided by h. Okay, and then plus cosine of x limit as h approaches 0, and then you have got sine of h over h. This negative I can multiply with a sign there, so that is going to be what? A negative sine of x. Now we know that the limit as h approaches 0, let me first write that. Limit as h approaches 0 of 1 minus cosine of h divided by h, and then plus cosine of x, and then limit as h approaches 0 of sine of h divided by h. Well, limit as h approaches 0 of 1 minus cosine of h over h is a 0, and 0 times negative sin, that will still be a 0, plus here we've got cos x, limit as h approaches 0 of sine of h over h is always equal to a 1, and so this is going to give us just cos x. Therefore the derivative of sine x is cosine of x.